We start with a bitwise AND. Okay, so we're going to go in there and make that a bit bigger. That's false, that's true. Now, I'm going to read this bit because this is the important part. If X, then Y else Z. Or if IIf, X, comma, Y, comma, Z. These are the standard ways that we branch depending on values. So if X relies on X being true, except it doesn't. It relies on it not being false. Then take the Y would be the true root and Z would be the false root. And notice here, activates Y when assertion, whatever your calculation is, X, is not equal to false. Otherwise, Z is when X is equal to false. Absolutely identical to false. Every single bit is 0, or reset as it's sometimes referred to. So a bit, I'm sure most of you here will know, I expect all of you do, a bit is a binary digit. And its set is when it's 1 on a bitwise basis, and reset is when it's 0. I'm going to moisten my throat. So, bitwise AND. X and Y equals Z. Each bit of Z is set only if the corresponding bits of both X and Y are both set, but is reset if either is reset. So for set, read 1, for reset, read 0. I want this to be a little bit interactive. Does anyone so far have a problem with anything that's been discussed?
Yeah, I do. I'm having difficulty with the first row where we've got a binary and a decimal of 1,
Oh, this
but
one.
yeah, why is that 1 and not 0?
Because these numbers I've selected to illustrate, to reflect those items which in binary are in a single column. So the first column is 1, the second binary column is 2, the third binary column is 4, the fourth is 8. Then it's 16, which in decimal is fine, 16, but in hexadecimal over here would be 10, because the unit column in hexadecimal has reset. Okay, does that, I don't know if...
No, but we don't have a row for the value of 0, like decimal 0, which I would have thought would have related to the Boolean false.
It does, but if let me take that. Everything to the left of that is to illustrate just the concept of different numbering systems.
Oh, okay. So it's not related to the columns in I of true and false.
It's not directly related.
All
This
right.
is not about Boolean logic. This is about understanding numbers in the first place.
All right, but you could have a row before that, an hexadecimal that was just 0, 0, 0, 0, 0, 0, 0, 0, 0, and
Yeah,
that would have a decimal value of 0.
except for the amount of horizontal space I have on the screen. So that would have complicated matters a little, but not a lot. I could probably have fitted one more row in there. But what I'm showing here is essentially the powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2, etc.
Yeah, I'm just a little confused because we didn't start with 0, but then again, that was one of the issues with Roman decimals. The Romans didn't have a symbol for 0.
You're right. And
which is what screwed us up on years, because there was no year 0.
You probably wouldn't have counted. Even if they had very short side track, I suspect if they had a 0, they still wouldn't have used it because it's the first year. You would name it year 1, even if you did have a 0.
And this is why we refer to babies as newborns until they're 1 year old.
Except in India, they have a 0. Yeah. In India, if a baby is only 100 when Sorry, they're 100 on their 99th birthday, or what we see as a 99th birthday.
Anyhow, sorry.
Yeah. Are you happy with that, Ken?
Yeah, I was just wondering why we didn't have a row for 0, but that's right.
And that's good.
I'll deal with it.
Stuff, because if I do it again, I might add that just simply so that no one is going to be confused about it, basically. So, okay, right. So we're now down to here. So each bit of Z is set only if the corresponding bits of both X and Y are set, but if either is reset. Now, this isn't a brilliant example, but it does give the example. So I'm saying that and that equals that. So 0 and -1, and -1, I can take you through that if you like, but I haven't got it here. -1 will always be in binary all set digits, all set bits. And all bits reset as 0. So what this is saying is if you take that value there and you AND that value, you end up with that value. That is the most basic Boolean logic that we have. So if you say, is something false and true? So if something is false and something is true, what is the result of ANDing those together? Well, clearly it must be false, because they're not both true at a basic Boolean level. But what we have to remember, and what we'll get into a bit more in a minute, is that works on every single bit of the value. So here's another example here, which isn't quite as simple. And you can probably see if you look below at the binary why I've used those two values. Okay, they're not random. In decimal, you wouldn't know. There's nothing special in decimal. But 21845 and -21846 equals -1, which is true. So if you look at that in hexadecimal, it's 4 zeros 5555 and 4 F's AAAA. If you AND those together, you'll notice that there is not one single column where both bits from the X and the Y are both set. Okay, so you end up with a 0, an absolute 0. I'm not talking temperature here. Okay, so I've got some question marks down here. So if A is at 21845 that we've got there, and I've shown that's the hexadecimal value, and that's how you write a hexadecimal value if you are writing it in VBA, by the way, in case some of you may not have done that a lot. And B equals not A. So not, we'll get to in a minute. It's one of the other things. Not is where every bit is flipped. So if it's a 0, it goes to a 1. If it's a 1, it goes to a 0. Every single bit is flipped from what it was to the opposite of what it was. So who can tell me if A comma X comma Y, what is the, IIf? Who can tell me what the result in that situation would be?
A would evaluate to true because it's not 0.
And yes, keep going.
So therefore we get the value X. So if A is true, then we use X. If A is false, we'd use Y.
That's exactly right.
Oh,
okay.
That's
it's very simple, but it helps. If you look at A is not true. Nevertheless,
it's not false.
And that's what's important. If we go up to here, activates Y when assertion is not equal to false. Yes, and A may not be true, but it's not false.
Okay, because I've always worked on the basis that anything that's not false is true. So what I'm getting here is that yes, kind of almost, but it's not really true.
Yes.
It's just not false.
That's what I'm trying to bang home, essentially, is that people think of false and true. But if I say, is A equal to true, the answer will be false. But if I say, if A, then it treats it as if it's true. In as much as it treats it, it doesn't accept it as false.
And this is because the engine behind it is looking to see if it's false first. And
Sorry, I missed the beginning of that. It didn't come
this is
through.
because the logic that's going on programmatically is that it's evaluated for whether it's false first.
Well, technically, if I'll very quick sidetrack and I'll answer that, the processor has a zero flag, which is set or reset every time it does a calculation. Add this to this, subtract that from that, do this, do an and, do it. Every time it does one of its flags, the zero flag, will be set or not. And it just checks. So the IIf will do the calculation and it'll say, is my processor level zero flag set or not? And if it is, it knows it's false. If it's not, it doesn't know what it is. It just knows it's not false. So it doesn't have to do any more calculation. It just says, blah, 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 is the zero flag set? And that's why it's so easy to run one of these things and say, well, if it's zero, it's there. If it's not zero, then it takes the other course.
The evaluation that occurs is faster if you're just looking for whether something's false rather than evaluating whether it's actually true.
Well, essentially, yes, because the processor has a command. The Intel processor have a command jump on zero. So all this testing is all about branching. So take one route if it's one thing, take another route if it's another. So you do your calculation, and then at the end of it, you just say, JZ, jump on zero. And the zero will be the Z. And when you don't jump, that'll be the Y. Obviously, the code is a bit more sophisticated than that, but at its most basic, that's what it's doing. It doesn't have to say if anything, it just says JZ. And it'll go one way or the other, based on whether the zero flag is set.
Oh.
Okay. So I'm glad you interjected there, Kent, because that really is the heart of this. That is the understanding that so many people don't quite have. And I wanted to highlight that. Okay, so on to the next one. And let's see if we can have another answer. If B, and B is not A, and is the value FFFF AAAA in hexadecimal, if B, comma, X, comma, Y, what would be the result of that? Okay, Crystal, I know this is quite new to you. Could you take me through your thinking? I know I put you on the spot here, which is unkind and unfair, but I know you from a long way back, and I know that this is something that it's not something you've had a lot to do with in the past, but I think you're there or thereabouts now. Can you tell me whether you would expect the result to be X or Y based on that?
X.
And you're correct, but I'd like, if you wouldn't mind, can you explain in the way Kent did why it's X?
Well, I can't explain in the way Kent did, but I'll explain in the way I can.
Good enough.
Yeah, this is okay. So B is not A. And if you look at A and flip it, it's still not, all zeros. Therefore, it still has to be true.
That's exactly right. That's exactly right. Okay, you can mute. You've done yours, and well done. You caught that ball, Crystal. Apologies for throwing it at you out the side like that. Okay, if A and B. So now we're getting into the and part of this. If A and B, comma X, Why? Who wants to jump in and give an answer to that? There's no wrong answers. It can be wrong, but it's all part of a process towards that understanding. So, Bill, can I pick on you and ask you to explain what is going on in that line?
You know, A and B, we've already determined above is false, right? So
Where have we
that's not
determined
right.
that? Bill,
So
where
that's not,
have we determined that?
oh, above when we did the bitwise comparison
Are we talking
Right.
about that?
in that space.
Excellent. Yes.
And so shortcutting and just using the values we already know, A and B are false. So the first condition evaluates to not true, or actually false in this case, an actual dead zero, right? And so in that case, Y is going to populate to the answer, whatever Y is.
Perfect. That's a good pass there, Bill. You can mute again now if you'd like.
It seems like if A is equals true is the question, and A is not false. So I would say that that would evaluate to A is true, and so you'd get X.
Okay. Let's go with this. That's not actually correct, but let's take it step by step. So the first thing we do is A equal true? Now, translate that into numerical values. So we're looking for, is 21845 equal, does it equal -1?
No, it doesn't equal all ones.
Indeed. So the result then of that, well, tell you what, let me hand it back to you. Take it from the top and go through that with me again, for me again.
Well, you could say, in that case, you could say it's not true or it's not false.
But what's the code that's there? It's asking, is A equal to true?
Is A equal to all ones?
Yes.
And it's not.
And what would be the result of that comparison?
You mean the resolution of this line?
No, just the resolution of, is A equals true? Because this is another.
That would be a 0, yeah?
That would be. The result of that would be false. Now, when you do comparisons in code, I'm going to take a little side thing here. If you compare one number with another, so is A equal to B, okay, then the result, because it's expressed as an assertion, because you're basically saying A equals true or A is greater than B. That is an assertion. Okay, now assertions in code get resolved. And an assertion is either true or it's false. No complicated numbers. This isn't a calculation, it's an assertion. And I haven't brought that up before, but I'm bringing it up now. So there is an assertion, A equals true. A is damn well equal to true. I'm either right or I'm wrong. In this case, I'm wrong, because A is not the same as true. It's not false either, but it's not true. So therefore, and it's helpful to remember sometimes, because a lot of people don't seem to have a blank in their understanding of Boolean. When you have this code that says either if X then Y else Z, or IIf X, Y, Z, what they're interested in is a value, not an if, not an assertion necessarily. Could be an assertion. I could say if 1, X, Y, and 1 would be treated as not 0, and it would go ahead and do the calculation. I don't have to put an assertion in there, but most people are used to seeing assertions in there. And an assertion could be any of the comparators, equals, not equal, left, right, greater than, less than, etc. That's what we're used to seeing inside this code structure. So we assume that that must be the case, but it's not. It just wants a value. So, okay. So again, Will, if you take it over, start again from the top. Repeat yourself if you feel you need. Go ahead.
Well, it sounds like we've now decided that the assertion of A equals true is not logically positive, it's false.
It's absolutely false. Yes.
So now if that assertion is false, then you'd pick Y.
Yes. Absolutely right. Thank you. Well, I know, I didn't warn anyone in advance. I was going to make them stand up in front of the class and expose what they already didn't understand, because otherwise they wouldn't have been here in the first place.
No, I think it's really good. I've never really thought about it.
It's different to saying if A doesn't equal 0. This is saying if A actually equals the exact value that we've given to true.
Or even if A, see, that's the one where people get confused, because A isn't 0, may not be true, but it's not false. But if A, then you have X. Whereas if A equals true, you have Y. And this is where people get caught up a lot, because they think, oh, I tried that and it's right. Look, it worked there. It doesn't work here. Because
so the value of true is what? 1 or -1?
-1. And
-1. Okay.
That is because it means that in every single column, if I'm going to click up there, so in every single bit of that value is set. Okay. And that is a VBA thing. Not
all right. So if the value of A is 1, then that would still evaluate to false. A doesn't, well, so if A equals true and A is 1, then it's not true.
It's not only not true, let's be precise here, because this is what we're all focusing on. It's false.
Yeah.
Yeah. It's in value terms, it's 0. And 0 is important because every single bit is 0. And
okay. So when we're dealing with SQL Server, a bit, right, which is either 0 or 1,
do you mind,
as opposed to VBA, which is -1, because
can I explain what I was going to explain? Which
go on.
I was just getting onto that, and you came in with a question, which is what I'm going to get to. Only in VBA and a very few other languages. Most languages do not use the whole integer value, or long, depending on where they're at, to be true and false. They take how do I show this? I can't, because it's all in one value. But if you look at these two, they would have one bit that is used, and that bit can only be 0 or 1. And they don't have all this shenanigans that we have to deal with in VBA. This is purely down to the fact that instead of using 0 and 1 at a single bit level, they've tried to use a full word value and tried to code it round that. A lot of things, assertions always resolve to an absolute 0 or -1.
Okay.
Yes.
This is fascinating.
And that's why it's harder to work with Booleans in VBA than it is in most languages, because they just have their true and false map onto true and false, 0 and 1, simple. But 1 only works when you've only got a single bit. If you have 1, if you try to use 1 as the true value, then if you looked at that and said, and you and it with anything else, it would all come out as 0, because the only bit that has a 1 in it is bit 0. Now, I will take you very quickly, just to remind you, over here, bit numbers are from 0 to 31. You've got 32 bits, and as the Romans never managed, they start at 0 and go from the right-hand bit is bit 0, and then it goes across to bit 31, and obviously 63 in a 64-bit system. So I'm going to make that bigger again. Steve, explain to us what is going on here.
Okay, so if it's not equal to false, then it's not true. So that means then you would return Y.
That's right. It's not equal to false. Therefore, the result of the assertion is false. In the same way that my assertion to Kent earlier, you are my father. That is an assertion. It's absolute rubbish, but it's an assertion. It was a false assertion. So there
But
is
in the movies, it could be true.
I won't even go there.
When we've got open bracket A equals true, that's not an implicit assertion. That's an exact assertion that A equals -1, nothing else.
Absolutely. And thank you for pointing that out, Ken, because that's one of the things I want to get across. People have been used to dealing with this, and VBA is designed to work in your natural language as much as possible. But in Booleans, it doesn't quite fit. So when you're working with Booleans, it helps to understand what's actually going on. And what's actually going on is you're comparing two numbers.
Mm-hmm.
Okay. Will, do you have an answer for that?
Yeah, I was gonna say, if we look at it logically the way you've been doing, if you take the A number and the B number in digital, in binary, and you add them together, you get all ones.
Do you?
And that would be your -1.
Do you get all ones?
Right?
Do you get? These are the two binary values.
Yeah.
If you add them together, do you get all ones?
Yeah.
Let me say, no, you don't. You get all zeros, because to get a 1 in any
Oh, you have 1 and 1. Yeah.
both would need to be 1.
You get all zeros.
What we have here, and it's a bit random. If you had two numbers together and they're sort of random, there'll be some ones in there. In this case, because I've cheekily taken numbers which don't, because of the not actually, X and not X will always result in 0 by definition. So B is not A. So these and these will never have any column with a 1 in both.
Yeah, I got it backwards.
Okay.
So that means you get zeros.
Right. So
And 0 is false.
Indeed.
So false does not equal true. So
Well, it's not so much that false doesn't equals true.
Oh yeah, it's all zeros.
Making an assertion,
-1.
we make an assertion that false equals true. Now, we don't need to be brain boxes to realize that's a bit of a naff assertion. So, okay.
So that assertion is false.
Indeed. So what do we end up with?
So you get Y.
And that's perfectly explained. Thank you, Will. I think I'm going to wash off quickly to, here we go, or.